Hi, everybody. Ms. Bird is here doing a great job, I'm sure. I just didn't want to make her do all these proofs with you. So I figured I would just drop in and say hi. Hope everything is going well. And you can take some notes as I go through this. This is also going to be posted on Classroom. So if you ever need to go back and look at this, it's here for you. The reason I'm showing it to you this way, in a minute Ms. Bird's going to show you all the rules that you have to memorize for this unit, and actually next unit when I get back, and a unit later in the year. So this is a really important couple of days where you're going to learn a lot of new rules. But you know how I like to do things. I don't just want to give you the rules. I think it's always helpful, at least for me, when I was learning new rules and new things in math, to see where they came from. So this couple short videos today and tomorrow, I'm going to go through these things with you. I want to show you where these parallelogram rules are coming from. So the definition of a parallelogram, you have it right in front of you there, is a quadrilateral with both pairs of opposite sides parallel. So thinking back to things we've done in the past with parallel lines, hopefully you're thinking about same slopes, and hopefully you're thinking about angle congruencies. So alternate interiors, alternate exteriors, and correspondings. So based on this one basic definition of what a parallelogram is, we can actually prove three other things about parallelograms. And these are the rules that you're going to have to remember. So in this diagram below, we're going to use our knowledge of congruent triangles to prove a bunch of different things about these parallelograms. So remember CP/CTC. So I don't want you to write this, but on the side of my paper, I'm going to draw a couple triangles. So if I know this triangle is congruent to this triangle, those don't look congruent, but I'm going to mark them in as congruent. So if I tell you that these two triangles are congruent, it means that this angle is congruent to this angle, for example. It means this side is congruent to that side. It means this angle is congruent to that angle. It means, all the way around. So it tells you that all of their corresponding parts are congruent. So when I look at this parallelogram, a really common diagram you're going to see this year is this parallelogram drawn. So you can see ABCD is a parallelogram. And it has our parallel sides drawn in. So this is a parallelogram. And you're going to see very, very commonly a parallelogram with this line drawn down, this diagonal drawn down the middle of it. And it turns it into two triangles. So what I'm going to show you right now is we're going to actually be able to prove that these two triangles are congruent. So this triangle here, ABD, is going to be congruent to triangle DCB. And so hopefully the first thing that we notice that we've spent a lot of time on earlier in the year is that we have a reflexive property. So I'm not going to do a complete official proof, but I'm going to make a couple notes over here on the side. I can say that BD is congruent to BD because of the reflexive property. Or we've talked about this, some of you like to say a shared side. Both of those are totally fine. So my two triangles physically share a side. So that's one piece of information. If you remember back to congruent triangles, we know we need three congruent things. So it's a little different from the similarity we've been doing with the angle. We need to make three things congruent. So what we actually have here is a really nice opportunity to use our alternate interior angle rule. So if these are my parallel lines, and we think about this as my transversal. That was a bad transversal. There's my even worse transversal. There's my transversal, a little better. We have alternate interior angles that we can use. So we actually have a pair of alternate interior angles right here. And if we use my parallel lines going this way, we have a set of alternate interior angles here and here. So now if I move this stuff out of the way, you can see there's my three congruent pieces. So I'm going to label these to make it a little easier. Maybe I'll say 1 and 2 because those match up, and I'll call this 3 and 4 because those match up. So I can also say angle 1 congruent to angle 2, and angle 3 is congruent to angle 4 because parallel lines make congruent alternate interior angles. So Ms. Bird, feel free to pause if anybody has questions. If you guys want to talk about this a little bit more in depth, you can do that. But this tells me a really important thing. This tells me that triangle ABD is congruent to triangle. Now I'm going to be very careful here. I want to make sure I have my corresponding parts match up. If I call this ABD, I have to name my other triangle very carefully. So I'm going to call it, and I know A matches to C. So I'm going to match A with C here. Now here's where we have to think about our rigid motions. Angle B doesn't match with angle, I'm sorry, let me say it again. Angle 2 doesn't match with angle 4. So this angle up here actually matches up with this angle down here. So if I want to match B of my first triangle, I have to line it up with D of my other triangle. So A, B, D matches up with C, D, B. So it's a little confusing, but we have to think about this as being a rotation of 180 degrees to get that triangle on either. It's not a reflection. It's a rotation for our rigid motion. So what this tells us now is a ton of important stuff. This tells us that all the corresponding parts of these triangles are also congruent. So look at all this great stuff we now know. I know A, B, and DC are congruent because of CP, CTC. So A, B, and DC are congruent. I know that AD and BC are congruent. So AD is also congruent to BC. So the opposite sides are congruent. That's another great piece of information. I also know these angles have to be congruent because of CP, CTC. So angle A is congruent to angle C. And this is all because of CP, CTC. So I feel like I got going a little quick there. So if you need to pause, if you need to raise your hand and ask Mrs. Bird anything, to ask your classmates anything, please do that now. But we were able to prove the triangles were congruent. I should have marked this in as well. Maybe you guys talked about this. The triangles were congruent because of ASA. We had that nice ASA relationship. And because of that, we were able to prove all of these other things were true. The opposite sides were congruent, and the opposite angles were congruent. So these are the rules that Mrs. Bird's going to give you on the next page. You're going to make some flashcards tonight, and you're going to study these rules for a quiz tomorrow. Not tomorrow, but the next time you guys are in class. All right, the other thing that you're going to see, and this is kind of like a little side note, when you have these parallel lines, we can also look at this right here as our transversal. So we know that these angles, if you remember their relationship, these were called same side interior. So you don't have to draw this. But these consecutive next door angles in a parallelogram are always going to equal to 180. So that's another rule Mrs. Bird is going to give you on the next page, but it's helpful to see it in front of you. So those are a lot of important things. So of a parallelogram, we now know that the sides are parallel, the opposite sides are congruent, and the opposite angles are congruent. So go ahead and pause for a minute if you need to. I'll pause my video as well so you can take a minute, and then we're going to do a couple more things. So pause now if you need. So next rule that we can prove using this this parallelogram stuff. We can also prove that the diagonals bisect each other. So we're going to prove if those are the diagonals, remember that word bisect, it means they cut in half. So we're going to be able to prove that the diagonals cut each other in half like that. And we're going to use a lot of the same rules as we did above. So first of all, to prove this, we're going to look at these two triangles. So this, I think I would like you to pause for a minute and just jot a couple notes down with a partner. So Mrs. Bird, if you can pause the video real quick if you're there. What three things, what do you see about these two triangles? What could we use to prove them congruent? So go ahead and pause now. You can do a little couple minutes brainstorm session. So hopefully we came up with some of those ideas. If you look at my picture here, we have vertical angles. So that's one of those really important rules. We talked about this as being a bow tie proof. So we have vertical angles. We also have those couple sets of alternate interiors. So we have, if you want to label these 1, 2, 3, 4 again, we have vertical angles, we have alternate interior angles. But all that tells us, if we have AA, all that tells us that these triangles are similar. Remember, we're trying to find congruencies. So what we're actually going to have to do is use one of the rules we proved up here. So remember, we just proved that the opposite sides of a parallelogram are congruent. So I can know for a fact that BC is congruent to AD. So that tells us that these triangles are congruent. We either can use ASA or AAS. So we have congruent triangles because of ASA or AAS. And what that tells us, the really, really nice thing that we can use now, is again going back to that CPCTC. So if these two triangles are congruent, it now tells us that AE and EC are congruent, again because this is a rotation. And it tells us that DE is congruent to BE because those sides correspond. So there's a lot of rules there. And the reason I showed you this again is if you forget on a test or if you forget on a quiz what rules you have, you can always kind of think back to these proofs that we did. So when you have a parallelogram drawn with a diagonal or two diagonals, there's a lot of information that we can get from that by using CPCTC. All right, so if you do want to jot all that stuff down here, I'm not going to do it for you, but you can talk about your vertical angles here and here. You can talk about your alternate interiors. We're going to get to proofs later when I get back, but all the rules come from the proofs we've done throughout the year. All right, so on the next page, when you're done with this video, if you want to have a little talk, if I went too quickly and you want to have some discussions, you can do that. But Mrs. Bird is going to give you all the rules we just talked about. You're going to practice with these rules. In the next class, you're going to come in and take a quiz after having memorized them. All right, guys, so hope you're doing well. I will see you soon. And that is all. Bye.